Today we will discuss the secant method. Recall that the Newton-Raphson method uses the derivative in getting or in finding the root. In the secant method, we will get the difference. Instead of getting the derivative, which is f of xi minus f of xi minus 1, we will reverse the process, or we will get the difference, which is f prime xi is equal to f of xi minus 1 minus f of xi over xi minus 1 minus xi. And if we are going to get the estimated root or the approximated root, we will be using algebra and arrive with the equation xi plus 1 is equal to xi minus f of xi times xi minus 1 minus xi over f of xi minus 1 minus f of xi. And remember that the secant method uses two initial guesses, and it does not, the bracketing method does not apply with the secant method. Let's have an example. Use the secant method to estimate the root of f of x is equal to x squared minus e raised to negative x with initial estimates of x sub negative 1 is equal to 0 and x naught is equal to 1. The true value is 0.735. Now, we will use the iterative equation in solving the problem. For the first iteration, x negative 1 is equal to 0. If we are going to substitute that in our equation, it will give us the value negative 1 and x naught, these are the two initial guesses, is equal to 1, f of x naught is equal to 0.6321. Now we are getting the value of x1. Using the formula, our iterative formula, which is equal to negative 2642 over 3679, which is equal to negative 0.7181. And the relative error is 2.0331%. Now, we can observe that opposite signs are observed in the values. So we will use the values in the first iteration in doing the second iteration. X naught is equal to 1 and x1 is equal to negative 0.7181. Now we are going to get x sub 2 using the iterative method, which is equal to 0.6704. Now, the relative error is 4.94%. Now, we are going to do the third iteration in order for us to get the approximated value of x that is very near to the true value. Third iteration, x1 is equal to negative 0.7181, x2 is equal to 0.6704, x3 is equal to 0.7048. And by manipulating the equations and every values, we get the relative error to become as low as 0.18%. And if we continue the iteration, we will be much close to the true value. That's on the secant method.